In this video, we're going to deal with rearranging equations which contain roots and powers. Here we have our first equation. Root x minus 1 is equal to y. We follow the same guidelines as before. First thing, we identify the number of terms. And we have 3 terms. One of these terms contain x, root x. The other two do not contain x. We want to move all terms that do not contain x to the other side, which means we'll be moving this to the other side. So as we move the term minus 1 to the other side, minus 1 will eventually become plus 1. Now after rearranging, we now have square root of x is equal to y plus 1. Yeah, the subject of the formula is the square root of x, which is not exactly what we want. We want x to be the subject of our formula. So what do? We want to get rid of that square root sign. And the easiest way to go about that is to square both sides. Now, the square root of any term to be squared is equivalent to that said same term. So for example, the square root of 9 is 3. Okay? 3 to be squared is 9. So the square root of 9 to be squared is the same as 3 to be squared, which is 9. Okay? So again, the square root of 10 to be squared will give us the term in brackets, 10. Okay? Square root of m to be squared will give us that term in the square root, which is m. Now using this principle, we have the square root of x squared will be x is equal to, y plus 1 to be squared. And that is our answer. Now here we have 3 terms again. X squared minus y squared equal a squared. The first thing we do, once more, we're going to rearrange. We're going to move y squared or minus y squared to the other side. And that is going to give us plus y squared. So that's the first thing we do again. This time we have x squared is equal to a plus y squared. Now, we want our subject to the formula to be x, not x squared. So we want to remove the indices, the index. So what we're going to do is we're going to square both sides. So what we're going to do now is we're going to find the square root of both sides. And this will remove the square from the x term. The square root of x squared would be x. And this, the square root of a squared plus y squared, that cannot be simplified further. So this will be the same thing. Now there is a temptation to say by students that the square root of a squared plus y squared is a, plus y, or the square root of a squared and the square root of y squared, which would be a and y. That is incorrect, and we will prove that a little later on. So let's look at it now. We have this right angle triangle where the hypotenuse is 5 and the other two sides are 4 and 3 respectively. So by Pythagoras' theorem, the hypotenuse squared is the sum of the squares of the other two sides, which means 5 squared is equal to 4 squared plus 3 squared. Yeah? Now, according to this formula, h is equal to the square root of a squared plus b squared. Yeah? So h is equal to the square root a squared or 4 squared is 16 plus 3 squared, which is 9. So h is equal to the square root of 25, and h is 5. Yeah? We can also use these numbers to prove that this is not equal to the square root of a squared plus the square root of b squared. Yeah? Because the square root of a squared will be 4, square root of b squared will be 3, which is 7, and a is not 7. So before we leave this question, just want to emphasize once more, the square root of a squared plus b squared is not equal to the square root of a squared plus the square root of b squared. Those two terms cannot be separated. So in this question, we have the square root of x squared plus y squared is equal to y squared, is equal to y, sorry. Now, in this case, we want to make x is subject to the formula, but unfortunately, we can't move y or plus y to the other side yet. The first thing we want to do, or we need to do, is to remove the square root sign. And we can do that by squaring both sides. When we do that, the square root and the square will effectively cancel. We will remain with the term within the square root. So we will effectively get x squared plus y squared. You can think about it like the square root and the square being cancelled. You could do that, and that's fine. Is equal to y squared. Now we could start rearranging. X squared is equal to y squared. Plus y squared becomes minus y squared. So x squared is equal to 0. X will be equal to the square root of 0, which is 0. Now, for the sake of comparison, I just want to do a side by side. Let's look at something very similar. The square root of x plus y squared is equal to 2y squared. Now, this time, we can move the y squared term, yeah? Because the square root of x is separate from the y squared. So this will be the square root of x is equal to 2y squared minus y squared, minus 1y squared, and that leaves us with the square root of x is equal to 1y squared, or y squared. Now, to remove the square root sign, we're going to have the square root of x to be squared. We're going to square both sides. And what we have is the square root of x to be squared will be x. Again, you can think about it as a square root and a square cancelling. Yeah? Just don't say that aloud. And on the right hand side, y squared squared, we're going to multiply these two to simplify. Yeah? When we do the topic of indices, that will be explained. Yeah? For now, you just multiply the indices. And that is our answer. Yeah? So what I want to emphasize here is pay attention to how far the square root sign extends. Yeah? Because it matters to your solution. Okay, so this time we have the cube root of x, so pay attention, not square root this time, cube root. The cube root of x minus 2 is equal to 1. The first thing we do, we're going to move minus 2 to the other side, yeah? Because that does not contain the term x. Having done that, we now have the cube root of x is equal to 3. And what I'm going to do, I want to remove that cube root. So what I'm about to is simply to cube both sides. Now again, similarly to the square root example, when we cube the cube root, you can consider them being cancelled, and we now have the cube root of x cubed is x, and 3 cubed is 27. And that's our answer. So this time we have x cubed minus y cubed is equal to 1. We're going to make x is subject to the formula. We're going to move the y cubed to the other side. It now becomes 1 plus y cubed. Yeah? We don't want x cubed as a subject. We want x as a subject to the formula. So what we must do is we must find the cube root of both sides. Yeah? In order to remove the cube on the left hand side. So the cube root of x cubed will give us x, and the right hand side remains the same. This cannot be simplified further. Yeah? And we cannot simplify this and say it is not equal to the cube root of 1 plus the cube root of y cubed. Yeah? That's not accurate. Yeah? So this is as simple as our answer can be.